Good evening, everyone. Thank you for coming. This is Meetup number 37, 38?
Yes.
Yes. Yes. Meetup number 37. Thank you all for coming. My name is Darryl from Polar 7. We've been running these for just over about 3 years now. We've now got about 1,200 subscribers, or 2,200 subscribers, and about 100 people turning up on a monthly time to kind of come and do some networking and find out what's going on in the market. So hope you all enjoy it. Give us some feedback on the Meetup page. You know, come up, talk to us. We're wearing the white t-shirts around. Come up and tell us what you'd like to see more of. Come and approach us if you'd like to do a presentation. That would be great. So has anyone not been here before? Oh, we've got a few newbies. You should see what happens in the second half. Anyway, I won't tell you what's going to happen, but anyway. So thank you for coming this evening. Tonight we've got two great speakers. Thank you to Brocade, who are sponsoring the event this evening with Polar 7. They also have if you haven't, they have a drone here that's up for grabs. You need to fill in. Has anyone not filled in one of these bits of paper over here? Yeah? Grab one, fill it in, get your name on there. You will get an email probably at some stage to say hello. Did you enjoy the drone? But yes, you will get one. So just expect that. So yeah, tonight's the pizzas turned up early, so we'll probably just do quick into Brocade. We'll have a quick break for networking, grab a beer, pit stop, and then we'll kick into the second talk from Giles Chile. No, whatever, he can tell you himself when he comes on. But thank you for coming up, and he'll be giving the second talk. Did anybody hear about the outage of AWS recently? Anybody been living on a rock, not heard anything? No? Okay, so we get a bit of a perspective, which will be good and interesting to hear. This is all about feedback. Give us some information, you know, ask questions, and it's interactive as much as possible. So let's get it on. Here's over to Ian for Brocade. Thank you very much.
Thank you. So just a clarification on the drone draw, there is a tick box on there that says don't need more information. So we will try to respect that. Although I can't promise that all of our sales reps are nice people. Anyway, it's all good. Anyway, so a few of you may have heard of Brocade before, probably as a fibre channel company. So a few of you are probably wondering why on earth is a fibre channel company at an AWS event? Mostly because fibre channel's not who we are anymore. We absolutely do still do fibre channel. That's still a big part of our business, but we are much, much more than that. So with that in mind, let's get straight into the meeting. So, yeah, as I said, we're not a fibre channel company in and of itself anymore. Over the past few years, we've been rapidly diversifying into a lot of other areas, and one of those areas is very, very much into the virtualization space. Now, some of you may be aware we acquired Viata a few years ago, which was the virtual routing platform. That now has a new home with us as vRouter. We've done a lot of enhancements on it since. Last year, we picked up SteelApp from Riverbed, which has gone through a few different iterations and companies over the years. So you might have also heard of it as Stingray. You might have also heard of it as Zeus Traffic Manager. Just, you know, a few different ports of call along the way. Now, you're probably wondering why on earth would you look at an ADC when there's this thing called ELB that's built into AWS for you to use. Now, part of the thing is you'll probably feel a bit like this from time to time when trying to meet all of the different business requirements that you've got to deal with on a day-to-day basis. In turn, that can make you pretty, well, cranky, and if not, it'll certainly make your boss very much so. Why not end up like this? Look like a rock star, you know, have a happy boss, all the rest of it. Makes you wonder then why ADCs in general are a bit of a well-kept secret around the place. because they aren't just about load balancing. Specifically, why you might look at our virtual ADC is a list of things that is well beyond the capabilities of ELB in its current form. So things like proper TLS 1.2 support, proper server name indication support, so you don't have to run up hundreds of thousands of dollars in bills to run a multi-tenant environment with SSL on each individual tenant. HTTP2 support. Now that's a big part of the presentation that I'm going to run through tonight, and I'll get into why in a moment. Even basic stuff like compression, zlib compression and so on. Not sure if I'm allowed to mention it in an AWS heavy environment, but what if you want a bit of insurance across multiple cloud providers? Shh.
Sorry. Go for it.
Okay, so in a nutshell though, and the reason that we can achieve all of this is a very, very high level architecture view. We actually sit in line. We sit potentially in the ELB sandwich between two ELBs, or sitting on an elastic IP. Either way, we can intercept all traffic in both directions using two-way NAT. We can also do a lot of scripting, which allows you to intercept and deal with traffic before, during, or even after the connection's been and gone. Now, I've got some A2 sized slideware that's actually been printed out, sitting up here up the front, so we can go through this in a bit more detail afterwards. I also have my lovely assistant / product manager here, so even if you throw me the curly questions, I've got him to deal with them as well. Bottom line is, we can sit either behind a standard GLB, and wouldn't that have been useful with a rather large outage recently that some of you may have heard of, and certainly will in the second half, or behind an ELB for the full sandwich. Now, at this point, a few of you might be wondering if we're looking to replace ELB. No, we're not. We're in co-opetition, as we prefer to call it, and there are actually plenty of cases where, having realised that ELB is at the limits of what it can achieve, Amazon themselves have actually brought us in to help them out. So we've been introduced to quite a few customers as a direct result of that. Now, acceleration. This is probably one of the big things and one of the big reasons that you might want to look at something other than ELB within your environment. First of all, HTTP 1.1, it's actually very, very slow. It can take quite a lot of time to load and render a page when HTTP 1.1 is how you're carrying it. And that's mostly because the way it handles transactions is very, very, very linear. You can do up to 6 connections in parallel with a good browser. There are a lot of not so good browsers out there. Now, each of those will be subject to TCP slow start, will be subject to SSL handshaking if it's required, and just generally load up a lot of headers, cookies, anything like that along the way. Now, there's ways you can deal with that. You can, for example, use sharding and stream 6 connections out over multiple different subdomains. The idea being there, you might have your static content on a images.yourdomain.com site, the main www site for the index pages and not much else, and so on and so forth. You can also downsample images, although that doesn't really deal with the latency. Sprite them, inline them all into one great big image map. Now, one of the big things you can do is use a CDN, because one of the big issues that you hit is that latency rather than bandwidth is the main issue people hit here. These graphs are actually from research Google provided. Now, as it shows there, once you get beyond about 4 or 5 megabits per second, you're pretty much not going to see any major improvement with a typical website, mostly because that TCP slow start actually starts to get in the way. Latency, on the other hand, if you're dealing with 200 milliseconds of latency, which is not uncommon across continents, you're going to see a much, much worse page load time, 3.5 seconds, versus 20 milliseconds, which you might get within a metro area. The main thing is that HTTP2 is actually a heck of a lot quicker. For one, it actually pipelines the traffic into a single connection, so it can take full advantage of TCP and get past the slow start, get into full congestion control, and interleave the traffic to get it out to site. So, some of the things that it can provide is, as I said, better multiplexing, more efficient headers. It actually does make some significant improvements in that space. Now, HTTP2 does require browser support. The good news is, and I'll get to the level of support, that A, most of them do support it now, and B, HTTP1 negotiation is available. So for your legacy browsers, like the Windows XP browsers that just won't die, you do have the ability to still provide HTTP 1.1 content over the same connection without having to do anything special. It doesn't improve the performance of a single download. So a mirror site or similar is not going to see significant improvement outside the usual tricks of TCP optimization and so on. Now, having said that, for a typical website where there might be a couple of hundred objects on a typical page, a lot of the hacks that you might have used, like sharding, are just not relevant anymore. Now here's a really good video that shows exactly how it goes when it's loading up the page. This was from a suburb of Sydney to an AWS instance, all with the same web server involved, or with the same web client. The only difference here was whether it was a HTTP2 connection using our traffic manager, our load balancer, or straight onto ELB or HTTPS ELB. As you see there, even HTTPS based or HTTP2 with HTTPS or TLS was still twice as fast as plain old HTTP, let alone with the SSL negotiation on, what was it, 96 individual objects. Reality is, even with no delay, you see a 200% improvement in performance over standard HTTPS 1.1. Move that out to 300 milliseconds, which you might see, depending on your service provider from here to Europe, you're going to see basically a 5-fold improvement in throughput just by switching to HTTP2.
Sorry, can I ask?
Yep, sorry.
So the main difference was because of the sharding you're saying?
So the main difference, the main performance improvement with HTTP2 comes from the fact that it's a single connection. There's the connections interleaved, so each object will come down through that one TCP session that's created. So you're not having to re-establish a session every 6 objects or what have you. You can get them all at once. Now that means in turn TCP can go through slow start, get into proper congestion control, make use of the full window size that's available, and most web servers and most clients do have pretty good TCP windowing now. So you get much better performance because you're only going through that initial start and that initial negotiation phase once.
One of the other things that HTTP2 gives you is the protocol now allows you to actually transmit binary data in both directions over the same socket. So what that means is you can actually be sending a request while receiving data via HTTP2. The protocol is designed to reduce the number of TCP connections that you wear. Every time you do a TCP connection or an SSL connection, there's a setup time involved with that. So when you're domain sharding to work around the crapness generally of HTTP 1.1, you still wear a TCP connection setup overhead. So every time you're opening up those 6 connections, there's still a TCP connection overhead for that 3-way handshake. Because HTTP2 is able to use those connections in both directions more efficiently, a smaller number of connections reduces that minimum requirement that you have for that TCP connection overhead. So it's basically reducing the overheads for TCP and SSL connection setup. Does that make sense?
So it's still connection.
Sorry, say again?
It's still connection.
It's still connectionless, did you say? So yeah, so it doesn't change the connection. When you say connectionless, you talk about the fact that HTTP is basically a fire and forget protocol from a request response perspective. Yes, but the benefits there are that you can actually have data streaming in both directions at the same time over the same channel. So it's just basically, with latency, the thing that kills you with latency when you create a TCP connection, okay, let's say you've got a 200 millisecond round trip time, you still wear 200 milliseconds for each round trip that those packets have to take. If you reduce the number of connections you have to open, you're actually reducing the minimum connection time that you can have before you can start sending data. Does that make sense? So if you actually go back a few slides so if you go back to the waterfall slide for me here.
Yep.
So go back to the HTTP 1.1. So with this waterfall, what you're actually seeing here is for each of these connections, can you see this yellow section? So what we're looking at here is purple is DNS lookup, but see this yellow block? That's the time it actually takes to establish a TCP connection, right? By using a smaller number of long-lived connections that you're pumping data across in both directions more efficiently, you're essentially removing the yellow component of all of those connections. Does that make sense? So when you're actually going through and doing those connections, it's just that the short answer is HTTP2 is designed for delivering web content over a connection with latency, if that makes sense. So we can't change the speed of light as much as I'd love to, but we can actually, make it so that we don't have to set up as many connections while we're doing that. I'll shut up now.
And in fact, that particular slide also shows there, with these smaller objects, you're seeing 2/3 of the connection just being in that handshaking and negotiation phase. If you can do that once, then you don't have the problem anymore for any subsequent connection. Sure, as Aidan said, you've still got the round trip for each object when it says, I need this one now, I need this image or whatever else, but once it's done, it's done.
Would your device require a direct connect to AWS at the back end?
I've actually got a section on architectures and how to make this work. Short answer is you can still use ELB. There's just some tricks and tips you need to take into account. ELB itself does not support HTTP2 at this point. So these are some typical latencies from Sydney. Your mileage may vary. Various service providers do have different connectivity to different parts of the world. Some will use more direct connections, some will use even less direct ones, mostly depending on what they've been able to negotiate with the submarine cable providers. It also does, as that suggests, depend on which submarine cables are actually not broken at any given point.
Well, one of the things that comes up quite consistently is people saying to us, well, why would I care about latency given that I've got 12 milliseconds to Sydney? How many people have stuff, just a show of hands, how many people have stuff hosted in AWS in this room? That's a lot less than I would have expected from AWS. How many people took it in the teeth in one of the AWS outages recently? A few? Because it's really interesting. The week after that happened, I've never had so many conversations with customers about moving content into other geo regions within AWS. So if all of a sudden you have to start looking at putting the DR site for your stuff in Singapore, then all of a sudden 100 milliseconds becomes something you didn't have to deal with yesterday. So just something to keep in mind is that if you are actually looking at making your applications more geo-resistant, from that perspective, latency is eventually something that you will have to deal with.
It also depends on how your customers connect to the internet. ADSL has higher on-net latency costs than direct Ethernet, and a good example there is even within the mobile world, the difference between 2G and 4G is quite significant, just in terms of encoding onto the wire, totally ignoring the actual bandwidth differences. Now, I mentioned before about HTTP2 and whether or not it's actually something you can use. The good news is that virtually every modern browser does support it, and globally we see about 73% of the world's browsers, as seen by user agent, do actually support it. This includes IE11 on Windows 10. Unfortunately, if you're stuck with people using XP, no dice. But hark back to what I said earlier, HTTP 1.1 negotiation is something that everybody supports. Now, to mention the architecture discussion, the ELB Sandwich is absolutely a supported design, and there may, depending on your specific requirements, be very, very, very good reasons to use it. Now, the downside is if you're using that external ELB in HTTPS mode, no dice. You can't use HTTP2 in that mode because HTTP2 does require protocol level support in the load balancer. Now, if you're using it in TCP mode with SNAP, or you remove it altogether and put the elastic IP straight onto the load balancer that supports HTTP2, all is well. Now, a good ADC will also renegotiate the connection back to HTTP 1.1 for the back ends. So you don't even need to change the server architecture. You may need to performance tune it to deal with a much higher rate of connections than you were seeing before, but that's a different matter, and that's usually very, very addressable.
So that's an interesting thing. How many people here are using Apache Web Server? So that demo that you saw at the beginning, that had all the image tiles being loaded over HTTP2, when we first set that up, it was running on an Apache backend. And we turned HTTP2 on, and it went slower. And it took us a little while to figure out why. It turns out we were actually smashing the connection pool on the Apache servers, and we were ending up queuing on the Apache server. So we could have spent a couple of hours tuning Apache, but we just ripped it out and put Nginx in, and things got much better. But it's important to understand that sometimes, you know, when you do a performance tune and you make something go much faster, sometimes you just expose the next level of performance tuning that you might need to do. So that's just something to bear in mind when you're looking at you know, deploying HTTP2 in front of your HTTP 1.1 web servers, for example. So food for thought.
And that in itself is a good example of where premature optimization can actually cause problems. Some other ideas well, I've still got a couple of minutes. So these are basically other things that you might be able to consider doing with a good ADC that you wouldn't necessarily have thought of otherwise. I mean, you can't get toothpaste back into the tube no matter how hard you try, even if you do use a hammer. But you know, there are certainly tips and tricks that become available when you've got something that looks awfully like a hammer. So I highlighted earlier, we do have the ability, because we sit in line, to script up actions based on what we see, what we send, and even after the fact. And a really, really good example of where this comes in is, hypothetically, we might have a fruit-flavoured mobile phone manufacturer who had issues in a particular country in Europe with a particular telco, and what they were seeing was a lot of drop connections. Now, looking for the reason why, when you're seeing hundreds of thousands of other connections that did succeed, and your typical web server backends simply providing connection requests whether or not they actually finish or fail, makes that a bit like searching for a needle in amongst a bunch of other needles. So, one of the things we can do, because we log the connection right through till the time it actually finishes, is log anything that does not complete correctly, and log that off specifically.
So what we're looking at here is a thing called traffic script. So traffic script on the Brocade Traffic Manager is something that essentially lets you take your business logic and carry it out onto the wire to control how your application actually behaves on the wire. So the example we've got here is, 1, 2, 3, 4, and that last one is broken up for readability, so a 5-line traffic script essentially. What this traffic script is doing is, for every connection that comes through, it grabs the connection completion code. And basically it's looking at, did the connection complete or not? If for whatever reason, so if the reason code is not equal to complete, which means we have a connection that didn't complete, what it's doing is it's actually adding that connection to our detailed connection tracing engine. That connection tracing engine will give you a breakdown of that transaction through the traffic manager down to thousandths of a millisecond accuracy. If you're looking for something that will give you exactly an idea of, you know, you've got an application that's taking 40 seconds to return a response, exactly where that's coming from, that detailed connection trace is the place to go. So what we've done is we've essentially given the customer the ability to grab any connection. If it doesn't complete for whatever reason, in that example, it might be that, you know, whatever the business logic you want to architect, you can actually define the logic to hook and identify the traffic you want, and then throw it into that detailed connection trace. So in this particular example, for that fruity phone company web-based storage cloudy thing, was that vague enough? I think it was vague enough. What it allowed them to do was actually, you know, they were interested in logging connections that didn't complete successfully. Once they were able to narrow down the scope of what they were tracing, it became very obvious it was a particular version of iOS on a particular range of IP addresses. What it turned out to be was a particular phone software version with a particular set of carrier settings that was actually nailing the TCP connections under certain conditions. Very quickly led them to root cause isolation, and they were able to very quickly identify the fault and fix it. So the power of traffic script is something that actually allows you, as I said, to take that business logic and carry it out onto the wire to control how your application actually behaves. And that's a very, very powerful thing once you start moving into the cloud.
So along those same sorts of lines, and we've all had cases where your bandwidth or other resources don't match your actual needs. So another good example, if you've got resource constraints, how do you differentiate between customer classes? You know, your business logic might require that you treat your platinum frequent flyers, for example, as a higher class of web user than the grade unwashed or mere gold flyers. So with that in mind, it actually even allows you to, on connection, look up their, in this case, frequent flyer ID using a standard CGI get against a web server that's dedicated to the task, and auto-classify that traffic accordingly into special bandwidth classes, even with a special response pool, just to guarantee those guys get extra service. The reverse might also be true. You might actually want your grade unwashed to get better service, so they're encouraged to continue flying with you, knowing that repeat buyers will be repeat buyers. That's perfectly reasonable as well. Essentially, we don't make the rules of how you implement it, but this gives you some idea of the kinds of things that you can do on connection and on close.
There's a couple of places where this becomes really, really interesting. I've got customers that run very, very large ticket booking systems, for example. And during cricket season, for example, in India, every person on the planet, or every person in the country, is trying to buy tickets to the cricket. And it's busy, and they know it's busy. And the people that are buying cricket tickets are more than happy to wait, in the same way as if you were to go to a Ticketek store and the queue was around the block. You can see the queue, you know it's busy season, you go in expecting to wait a little bit. What they found though was that customers that were buying movie tickets or theatre tickets had no idea why the hell the site was so slow and just weren't willing to put up with that level of inconvenience. So being able to take that business logic and actually carry it out onto the wire to control how your application behaves means that what you can do is you can ring fence those cricket users, for example. You can say, I don't want the cricket booking system to use more than 60% of my resources. I don't want to make sure we have 40% that's dedicated to people who want to go to the opera or to a movie or things like that. So it really gives you that ability to take that business logic and carry it out on the wire to actually enforce that business logic and control how your application behaves. And when it allows you to tick those sorts of boxes, that means that you can have a velvet rope experience for particular classes of customers that's aligned to your business logic. If you're an e-commerce provider, your business logic might be people who are paying me money with their credit card right now are my best friend in the world. In 45 seconds, when I've got your credit card details and I build you, you can get lost. But right now, you are my best friend in the world, and we can actually provide the tools to enforce that at the actual application and network layer. So that's where the power of these magical ADC boxes that we're talking about, extending beyond the sort of the reasonably basic feature sets that ELB give you. Actually, that's where the power and the value comes into play. Does that make sense?
So yeah, in summary, there's a lot they can do. Obviously, HTTP2 allows you to significantly accelerate the way your application looks and feels without having to do very much else at all. The business logic discussion, we've just been through that in some length. So you can obviously see some examples. Traffic script does allow you to do a lot more than that. And then of course, all of this, given that it pipes the traffic straight into a nice logging engine, allows you much more visibility of what's actually going on. Net effect, you get to look like a rock star.
So this is the point where you're all supposed to go like this, right?
Yeah. So the net effect is, if you are interested, obviously we'll be here for the rest of the night and you're more than happy to come and talk to us afterwards. We do actually provide a downloadable copy on our website that is fully featured. Without a key, it'll give you all of the features at 1 megabit per second. So not enough to actually use, but it is a fully featured developer mode that allows you to go and have a bit of a play with it. There's also an AMI that provides the same capabilities. I will provide this deck so you don't have to write those links down, you can just click them later. So yeah, come and talk to us afterwards if you're so inclined. And if you haven't filled in the drone, you're filled in to win the drone, you're more than welcome to do so. We'll make the draw when everyone's going and getting beers and all the rest of it.
And because I'm the one playing the beautiful Adriana today, donations of $50 and above are tax deductible and might actually help your chances of winning the drone. I'm just saying.
Questions?
So yeah, very quickly, are there any questions before we do the draw and grab beers and all the rest of it?
Is it on the AWS Marketplace?
Yes, it's on the AWS Marketplace. Yep.
Are you guys worried that AWS isn't just going to switch the ELBs to HTTPS2 at some stage and sort of like kill one of your major features?
Oh look, we know they're working on a bunch of different capabilities and features, including some that overlap with ours, and that's up to the product manager to...
So to answer the question, the short answer is no. AWS has great features in the tool that they provide, and as we said, it's a co-opetition thing with us. At the end of the day though, AWS ELB is never going to help you in any other cloud or your data center. So a lot of the customers that we talk to become, we may come in as part of an AWS solution, but very quickly we find that we tend to also be deployed into the competitive clouds and then into their local data centers as well. And having that consistency of tool chain across all of those environments means that they're no longer limited to that lowest common denominator of whatever is available in each of the different environments that they're in. So yeah, we just see it as being better awareness of ADCs in the marketplace generally.
Can you have this internally on vSphere as well, potentially?
Absolutely. So the question was, do we run on vSphere? Yes. Traffic Manager itself was actually the very first real enterprise-grade software-based ADC. So the Traffic Manager itself is available as a tarball for Linux or Solaris. x86, I think we've dropped Solaris support now. Sonos. Yeah, Solaris. What's the Spark? Spark is the one I'm looking for. So, Linux and Solaris from that perspective as a software tarball, virtual appliances for VMware, Zen, all the usual sorts of hypervisors and that sort of stuff. So yes, one of our main value points is the fact that we can run in just about any environment. Although normally when AWS people hear, they don't like us mentioning that. But yes.
So in terms of AWS, does that mean you're responsible for the host's operating system, client packages, and whatever?
Yeah, so the question was, is there a chance the track might bend? No, I'm just kidding. With the AWS, so the way that it works, with the software-based installation, you're responsible for the operating system and the network setup because it's your installation. With the virtual appliances and the AMI images, we provide software updates for both the operating system and the Traffic Manager software. Is the short answer.
Sorry. So how do we make it highly available on AWS across zones? Easy way.
So there's a few different ways. We do support GLB, so you can run up multiple instances, fire it up that way. GLB will then round robin the traffic according to the rules that you put in. We also, it's a pure layer 3 load balancer or application delivery platform. So we can answer on all of those connections concurrently and deal with full active type coverage that way.
Yeah, the short answer is we cluster across availability zones. As long as you've got layer 3 connectivity, you can form a cluster. So you can build a cluster that sits in Sydney, for example, with nodes in either of the 2 availability zones. We can also create a cluster with nodes in different availability zones in different AWS geos as well. You can actually, configure it as a logical load balancer across multiple geos as well.
I have a question.
Sure.
How do you compete with CDN services?
The question was, how do we compete with CDNs? The short answer is surprisingly well. We actually have a rather large number of customers that are sick of the IV line that runs from their wallet all the way to Akamai's bank account. So we see a bunch of different things. We've got customers that use us because of our pure software form factor and our scriptability, the fact that they can use Puppet and Chef and all those normal software tools to control us. We actually have customers replacing Akamai-based clouds, for example, with us. We see people replacing CloudFront with us. Typically, it means it's driven by either cost control or the ability for having better control. So, for example, we've got customers that replaced CloudFront because they couldn't get user agent visibility, so they couldn't serve specific content that was designed for the browser, of a particular mobile browser, for example. They couldn't do compression, a whole bunch of stuff. They moved all their content into an S3 bucket. We front-ended the S3 bucket and then provided caching from that, compression, content-based routing, user agent-based routing, and all those sorts of things. I gave them the fine-grained control they wanted. We've also got customers that have spun up CDNs in various clouds, whoever's got the cheapest pricing, and they actually spin those CDNs up on demand. So they only spin up the cloud resources when they need them, and during quiet periods they spin it all down again. So the short answer is, how do we compete with CDNs? For the right types of customers, we end up being a damn lot cheaper and much more flexible, and so that tends to be where we see the hooks from those sorts of use cases.
Now there was a question over here.
I was going to ask, have you noticed any problems with HTTP2 whatsoever?
So the question was, have we noticed any problems with HTTP2 whatsoever? The short answer is, most of the problems we've seen from people deploying HTTP2 on us and using an HTTP 1.1 backend is, as we said, they need to retune the HTTP 1.1 backend, because now HTTP2 means that they're hitting their servers harder for the content than they were previously. So having to go back and tune those Apache environments, open up the number of connection threads, and generally optimizing the way that the Apache server was serving the HTTP 1.1 traffic. Beyond that, we've seen some customers that, for example, for Windows XP and other bits and pieces, not supporting HTTP2, old browsers, that sort of stuff. Most of that stuff is taken care of by the HTTP 1.1 backwards compatibility. So you can talk to our traffic manager and still talk HTTP 1.1, and it just works. Most of the problems we see tend to be general problems. For example, customers who are deploying a white-labeled service where they may be running 900 different customer domains with certificates. So the ELB version is you run 900 ELBs. That, in case anyone's wondering, 900 ELBs is actually worth about 250 grand a year. If you've ever done the math on that one, like this customer did. With SNI, which is server name indicator, means that you can actually have one vServer, one Elastic IP hosting hundreds of SSL certificates. It requires SNI support, and Microsoft, in their infinite wisdom, as a draw card to drag people off Windows XP, says you're not going to backport SNI support to Windows XP. We have had customers that, as going down this path, they've ended up finding one of their customers was still on an XP SOE for all of their staff. The benefit was, with Traffic Script, we were actually able to hook those users based on the user agent and flick them to different vServers that were set up on static domains. So, we've actually had customers that, some of these success stories we've been talking about, where we've been dragged in, where the customer has actually said to us, we could never have actually gotten our application to market without you guys, type of thing. So we like to be the rock stars, in that sort of perspective. So the short answer is yes, we have seen some problems with HTTP2, but nothing that we haven't been able to sort out, either through just our general awesomeness or the fact that Traffic Script is actually kind of cool. And we're going to go one last question, because otherwise someone's coming. You come and have a chat to us afterwards. This gentleman here had his hand up first.
So how do you implement scaling?
Sorry, how do we implement scaling? That's a very good question. How do we implement scaling? The short answer is horizontally. We've got customers that operate world-leading video on-demand consumer services. We were the only web app firewall on the market that can actually scale with them. So, for example, our traffic managers themselves can cluster horizontally with 64 nodes. So that's big. We tend to like massive customers that bring us, terabits a second of traffic. We're actually quite happy to show them a virtual and software-based solution that can scale that far. From a web application firewall perspective, we've got a distributed WAF. That actually means we can scale horizontally from that perspective. So we've got customers that are deploying, so if you were to have used a orange and blue branded browser lately, their entire infrastructure is built on nodes on clusters of 8 node traffic managers that then they just rubber stamp those building blocks horizontally and then use global load balancing to spread across the front of those. So the short answer is, how do we scale? Really, really well. And that's kind of one of our major differentiators from that perspective. So
we've got a document here that we'll go through afterwards if you're interested. We can show you the way it works.
And because I cut you off, we're going to get a business card off you, guy in the yellow and black shirt. We're going to get a business card off you later on, and we'll see if we can hook you up with a t-shirt for totally cutting you off. So.
Awesome, guys. That was great. Who here hadn't heard about Brocade before tonight? Yeah, so who here has heard about Brocade now? Everyone. Awesome, guys. That was great. Ian.
Thank you.
Aidan, thank you very much. That was awesome. Cheers, thanks very much.